Hey, welcome everyone. Today I am delighted to be interviewing Miss Chuang. She is a Moko native who graduated from UIUC for her bachelor's degree and UMD for her master's degree. While completing her undergraduate degree, she also competed as a D1 swimmer. Miss Chuang has been a systems engineer at Leidos for the past 8 years, and she has extensive knowledge of air traffic control systems and software product development processes. And for now, I'll hand it over to our guest. Welcome, Ms. Chong.
Hello. Thanks, Michael, for inviting me. I know Michael from coaching him through swimming. I'm going to share a quick PowerPoint I put together just to introduce myself a little bit so you're not just looking at my face talking. Alrighty. So let me hide this. Um, like Michael said, I grew up in MCPS. I grew up in Clarksburg before Exit 18 existed. I went through the MCPS like magnet programs and then went to high school at Richard Montgomery for a year before transferring to Poolesville for my last 3 years. For higher education, I did my Bachelor of Science in Bioengineering from the University of Maryland at Urbana-Champaign, and where I was able to get a swimming scholarship. And my relevant educational experience that you might want to think about for your college experience too is internships. So I did an NIH internship between my sophomore and junior year, and then I did coaching the other years that I didn't do that NIH internship. I did my master's of science in systems engineering at the University of Maryland College Park, and I was a research assistant for a civil professor, and I did my thesis related to Federal Aviation Administration data, which kind of feeds into how I got the job that I'm working at now. So for the past 8 years, like Michael said, I worked for a company called Leidos, and the division that I work in is called Transportation Solutions. It was recently reorganized to now be called Civil Solutions. But I work in the programs that are related to the FAA, which deal with air traffic control systems. And so I still call myself a systems engineer, even though right now I'm actually a manager. But my roadmap that I had followed through my Leidos career was I started out as a systems engineer, where I did performance specialty engineering, and I did that for about a year and a half. And during that time, I actually helped like revive a program that allowed people early in their careers to rotate between different organizations. So I was lucky enough that within Leidos, I've seen a lot of different, I guess, like roles and different parts of the systems. So after my first year and a half, I actually did test engineering, which is where you see the system in its end state and you test for different faults or for stability. Then I went back to being a systems engineer on actually a different program that was just starting. We just acquired it. And so I did like base level requirements and system modeling for 2 years. And then after that, I tried my hand in business development, which is when a company wants to get new business within a certain field, they'll go out to trade shows to kind of showcase the products that they have. You write proposals to try and gain new business. And then I did the internal research and development management, where you're trying to develop certain technology related to your field to help you enhance your positioning in the industry to win more business. And then after that, I came back to actually the program that I did system engineering for a second, and I became a manager. And I manage a team of about 17 people right now across the tech manuals and trainings domains. So I always say, live to work to live, not live to work. So the other interests I have outside of working are coaching swimming, being a homebody with our 3 dogs. So this is my husband and our 3 dogs, and then traveling. So I think that I've been very blessed that my career and where I've gone have given me enough funding to be able to travel. So like the work-life balance and the money that it takes to take some trips internationally. I'll provide like a little bit more background in case anyone has questions later on. I think a lot of people know what software engineering entails, but a lot of people had not heard of systems engineering before. So I know that was the case for me when I was I actually didn't know what systems engineering was until actually looking into changing my kind of career trajectory when I did my master's. So what it is I can click through. um, so when you're trying to develop a product for a customer, right? So let's say it's a software product. The coding is, I think, what's the most a lot of people will know about because you're actually doing the designing and creating the software that or creating the code that will eventually become like what you see on a computer screen. But systems engineering is when you're writing requirements to make sure that you've captured what the customer wants objectively. So if they say like, oh, I want X, Y, and Z, and then you write it in this certain way, they can't go back and say, oh, now I want, A, B, C, D, E, F, because they've agreed to requirements that are testable, and it makes sure that you stay within, like budget and schedule. But you can do modeling with that, and that's what MBSE is. It's model-based system engineering, and you can and doing certain like measurements to make sure that you're staying within customer parameters is also part of the systems engineering domain. And then test engineering is like after you write the requirements, software codes it, and then testing will make sure that it functions correctly, essentially. And then in terms of the air traffic systems, so when you're in a plane in the sky, there's essentially a guy or numerous guys or girls sitting on the ground that help control that air traffic in the sky. And we design the systems that help those controllers help deconflict traffic and make sure the planes stay separated and know where they're supposed to be going in the sky. So that's my quick background. And I will stop sharing and give it back to Michael.
Yeah. It's definitely interesting to hear about the differences between software and systems engineering. I know a lot of people at Wootton, especially those who are part of the AOIT program, are very interested in things like computer science and kind of wanting to know like what the difference is. So it's great that you're able to highlight that. And you did mention that you wanted to switch career paths when when you chose your master's degree. So I wanted to kind of know what made you decide to pursue this specific master's degree in systems engineering.
Yeah, so after I did bioengineering, I worked for a vaccine manufacturing company for almost a year. I hated it, to be honest. It was not the life, it was not the kind of work that I found interesting. It's very repetitive and just not fulfilling at all. So I wanted to go back for something still technical, but like a totally different different type of work that I would do.
Yeah, so when you said that when you were completing your master's degree, you worked with a civil department professor, is that correct?
Yep, that's right.
And so can you tell me a bit more about that internship that you said that was kind of pivotal in helping land your job at Leidos?
Yeah. So the first semester that I did my master's, I actually still worked and then I did the classes in the evening. And while I was doing that, I actually like went around to different professors and saw what projects they had. So generally you can, I don't remember what the resource was, but there was like a board where essentially like an online board where they had which professors were taking like research assistants and then what projects they're working on. So I picked a few that I thought were really interesting and then emailed saying, can we set the meeting? I'm interested in what you're doing. Here's my background. And then this one ended up fitting in terms of, like workload, timeline, and what they were doing. And so it just happened that the project that he had aligned with my interests and they already had worked with the FAA. So essentially what I did was I would go in to the FAA office in DC once a week and then help. It was pretty much data processing. So I had to learn Python, even though I had no software experience, but it's not super hard. I think it was a good learning experience. But the actual project I did, I didn't really get to pick what I wanted to do. But then when I wrote my thesis, I did it tangentially related to the data that I had to work with. Um, and and then when I applied for the job, it was in this division, which deals with FAA stuff. So I think they saw that I had that aviation experience and knew how to do some like data processing and handling and analytics and stuff. So,
Mhm.
yep.
So, as a systems engineer, I guess it's important to know things like principles of computer science and how to program. So, what would you say is like kind of the more important programming languages that you've learned, or the things that you've taken away from, I guess, computer science or software engineering?
I think it really depends because depending on the program that you're on, sometimes they use like really antiquated languages. So I wouldn't recommend going out there and learning it. But I've been part of like interview processes now where when we're looking for software engineers, a lot of times it's not the languages that you know, but kind of like how you apply those. So we think that essentially the thought process is if you can use like Python or Java or C to complete a project, right, that you're taking initiative to do yourself, then you're going to do that in work also, right? If it's a language that's slightly, different, at least you have that thought process to, like how to do how to do coding and you know how to take initiative to learn something yourself. And I think that's something that a lot of in like in the industry in general, people look for.
So I
So I think
guess
yeah.
yeah, so as high schoolers, obviously we're not kind of at that stage for,
Mhm.
preparing for a career, but are there certain things or like certain thought processes that you think are important that high schoolers or people who like to do programming should kind of like take to heart now?
I think just the fact that you guys are trying it now and seeing if it's something that interests you in the future is already a great step in the right direction. Um, Not that I'm not thankful for where I am now, but I think that, if I had had a different trajectory, I could have gotten to where I was a little faster a few years earlier. Um, and so I would even say, like doing projects that you enjoy doing outside of class. And if you don't enjoy doing it, it's okay too. But if you have something that you're passionate about and you want to turn that, passion or interest into something that you can kind of put in your portfolio and say, like, here's something that I did myself, I think it looks pretty good for resume building, that you can use even when you are in college, like you're looking for a summer internship. So
Mhm. So before
yes.
we get into your line of work, I kind of wanted to touch on something that you mentioned previously, which is that you were a D1 athlete when you were um, completing your undergraduate degree. So can you kind of tell me a bit about that experience as a D1 athlete and any like lessons or things that you took away while also having to complete a very rigorous engineering degree?
Yeah. So I think that luckily our school was very in line with NCAA regulations. So like Michael, you probably know this, but when you're in high school, they actually don't have limitations on how many hours you can put into training. So actually when I was in high school, I actually ended up committing more time to like swimming and dry lands than I did in college because NCAA rules actually say you're not allowed to do anything more than 20 hours per week. So outside of that, you still have to do, like physical therapy for your shoulder injuries and that kind of thing. But I think that because swimming was not a very visible sport, let's put it that way, there wasn't as much pressure, to perform. Of course, you want to do well for yourself, but it wasn't like, football or basketball where there's a lot of spectators and you're, pressured as a school and as a program to perform really well. So I think it was nice that we still got all the perks of being an athlete. They had special, like they'd provide us tutors for free, which was nice. And they had like a building for like allowing us to have private study rooms too. So I definitely took advantage, and they had free printing, which is really nice. I know a lot of colleges don't offer. So I definitely took advantage of, I think, all the things that athletes were offered, but definitely kept in mind that when you go to school, everything you do is like your end goal is to try and get a degree. So even though you are an athlete, right? They always sound cheesy, but they say student athlete and student comes first. So I think that with the program that I was in, it was easy to keep that in mind because they did make sure that you prioritized um, your education. So they offered like practices at different hours if it conflicted with classes and that kind of thing. So it did take a lot of time, um, but definitely helped me stay more regimented and it paid for my education, so I can't complain. Yeah.
So uh, you were you did say that you completed your engineering degree at UIUC, which is known to be one of the top five engineering programs in the nation, which is quite impressive. I was wondering what what did you find hard like transitioning from high school to college and completing an engineering degree, and what would you kind of tell high schoolers now how to prepare for such a degree?
I think that because your time is less like locked in, uh so don't recommend doing this, but I guess like in school sometimes when you'd have classes that were a little slower, you could like I could like finish homework for other classes, or like be really efficient with my time at the school day at the school where I was, like I don't want to say forced, but where you had to sit there and be in a certain place at a certain time. And if you had like downtime, I used that to just, like finish the rest of my schoolwork. So outside of that time in school, I had more free time. But then when you're in college, I think that having that flexibility where it's like a lot of your classes are going to be pretty extensive. You're doing, like labs or discussions where you're actively involved the whole time. So you don't have that regimented like time when you're forced to sit somewhere at a desk, right, doing nothing else. That really, I think for me, helped me um, be more efficient with my time. So I think that adjustment was a little hard where I was like, oh, I have a 2 hour break. I'm going to go, eat lunch and take a nap before my next class, as opposed to being forced to sit in a building where I would have to do work. So I think kind of building that discipline of, or like even, creating a schedule for yourself where you designate times to help you, um, I guess, like focus on certain assignments or certain schoolwork would be helpful to plan for. And that was something I definitely did not do my first year. Yeah.
Yeah. Well, that's great to hear about your college experience. And now, I guess, moving forward to the present, I was kind of wondering what you do in a typical day. Like, what would you do for work?
Yep. So right now as a manager, it's a little different. So I actually had to write this up recently. So I kind of have a good idea of what I do within a week. So as a manager, there's different things you're responsible for. There's the personnel management, which a lot of people think about, which is, like giving people certain tasks to do, checking up on how they are doing with those tasks, right? If there's certain like career development things, signing time cards, that kind of thing. Then there's a technical side of management, which is for tech manuals and training, we're essentially writing procedures on how to use the system that we have. And then for training, we're building this web-based development product in a application called Storyline. And that one is the team is a little bigger and they're all working in different areas. So it's making sure that people know what they're supposed to be doing, what their goals are for the week, and then doing kind of like bi-weekly check-ins to make sure they're on track for their goals. And then the last part is the cost management, where essentially you have a schedule that sets deliveries at certain time periods, and you want to make sure that you stay within budget and on time. So that's where the checking in on each person comes in to make sure that they're hitting what they're supposed to hit so you can deliver on time. And if they need to work overtime, kind of rectifying the money that you said you'd spend with the money you're actually spending, and then justifying it to like the program management. So on a day to day, I might wake up and like have a stand up with one team at like 8:30, and then sit in the cost review meeting for an hour, get some actions out of that where I need to update certain spreadsheets to reflect what I was talking about with cost and like personnel. And then like around noon, we have hot topics, which is where they talk about all the things that are going not wrong, but all the things that require immediate attention across the entire program. And then the afternoon, I might have another stand up with a different team, and then do some like actual discrete technical work. So if someone has a question about, like why our lab isn't working, or they're wondering how, like how we had said that we were going to code a certain piece of training, like answering those questions, and then probably doing another meeting with like one-on-one with one of my direct reports, checking in on how they're doing. So yep, it's very it sounds kind of boring when I say it out loud, but it definitely is,
Yeah.
it's work. Yep.
So you did mention that you work more in a managerial position now. So I was wondering
Mm-hmm.
what were the differences when you were kind of working in a more, I guess, in a job that was more concentrated on the coding than versus having to work like manage other people.
Yeah. So I think the biggest thing was when I was on the technical side, there was way, way, way less meetings. So if you like talking to people, I think it's a good role. But if it's you just want to lock in and get work done, um, maybe like a more individual contributor or technical role is something that you want to stick to. So yeah, I think I have tried my hand at both now, and I might be veering back towards the technical side, but I definitely recommend that in your guys' careers, like try different opportunities and see what you like, because you won't know until you try it, I
Yeah.
think.
And I guess there is kind of like this stereotype that, people do look for job security and like more money in managerial positions. And I was wondering, in a position that is more technical, are there opportunities to be able to grow your career and kind of jump that corporate ladder in a sense versus a managerial position?
Yeah, I think actually being a manager, I've seen what the like kind of the back end of what makes people really valuable to, a company as a whole. And I think a lot of it is like initiative. So the people who are like indispensable to our company now are people who were are like system architects. They know how like a wide range of things do work, or they know um about like a specific product very, very deeply in a way that's like it would take years to transfer all that knowledge to someone else. So if you do want to stay technical and climb that corporate ladder, I think that the people who have willingly put themselves out there to be like the subject matter expert for certain areas, and then like helped people, like became the go-to person when a question about a certain area came up, are the ones that are now like we can't let them go because they know so much and they've been so indispensable to so many areas of the organization, essentially. So yeah.
Um, so you said that you've been working with Leidos for the past 8 years, and I was wondering, what was your favorite project that you've worked on in that time?
um let me think, that's a good question. I think I liked different parts for different reasons. Um, I I recommend, so I also help mentor people within my our company now. And I always recommend that I think everybody should do a rotation and test because you get to see the end product. So I think that when you're a system engineer or you're a software engineer, a lot of times you're working on a very small piece of a very large system. And so it's hard to see what contribution you're actually like providing to a product as a whole. So when you go to test, you really get to see the end product, and like it gives you better understanding of what you're working on, but better appreciation too. Um, and so I really enjoyed test engineering because I think that it was the people in test, I think, had a little bit of a different attitude than, like system engineering where they're a little bit more relaxed. Um, and I think it was really nice being hands-on. The one downside of that one though was at the time you couldn't do it remotely, so you had to go into the office every day. um, but I think that was a great role. I think business development was really interesting to see. Definitely gave me like a different perspective on like how like when work comes in, like how does that work actually obtained realistically? Like what are the concrete steps that someone needs to take to actually pull in that new business? Um, so I don't think I really answered the question, but I think I really enjoyed test, and I actually really enjoyed my second system engineering role because I got in on the ground floor. So I really knew a lot about like how things were designed and like why they were designed that way. It was like building something from scratch that you like really knew a lot about the reasoning why, instead of just saying like, oh yeah, I inherited this thing that I had no idea about that someone else started. Now I have to take over. So it's really nice to start something too. Yeah. I liked all the different reasons. They were all great. Yeah.
So I guess with the as being as a test engineer, and you said that you worked on products for the FAA, could you kind of, I don't know how much you are able to do because I don't know with like government regulations, but
Yeah.
I was wondering if you could kind of talk about more specifically what you were testing and like how that was implemented in the final product that you.
Yeah. So I kind of grazed over it in my PowerPoint. I'm gonna pull that up to see what I wrote because I feel like I put my thoughts together pretty well in that one. But essentially when you do test, at least in our company, there's different testing groups. So some of them will just test basic requirements, like do you meet all the requirements that the systems engineers wrote, so that you're actually fulfilling what the customer had specified that you must do. And then they also have like stability testing, where so like for air traffic control systems, when I was a test engineer, I worked on a the specific program was called ERAM, and it was oh man, it was like en route modernization something, but it's essentially like when the plane is in the sky, it's the actual like radar view that that controllers will look at to see like little blips on the screen that are airplanes, and it tells you information about like speed, heading, like altitude, that kind of thing. And it also gives you information about like there's airspace restrictions, like which fixes they're heading towards, that kind of thing. But for that kind of system, it has to run, like continuously a really long time. And so you're testing like, oh, if you don't restart it and you don't touch it for, like 80 hours, is anything going to go wrong? Is there going to be too much, like data buildup on the storage servers that could cause it to crash? There's also a group for failure modes. So it's literally like, oh, what happens if someone's walking and trips over a wire and unplugs it, right? How long would it take to recover? So like for the testing team I was on, there's actually one of the tests was you just take like a really heavy book and put it on the keyboard, because one of the failures that they actually experienced out in the field was like a controller had sat in a keyboard and pressed a lot of keys at once, and it caused like a system crash. So it's like that kind of thing where you're testing different scenarios, so like requirements, stability, failure, and then there's a few others that I'm probably forgetting now, but there's like different groups that I thought was pretty interesting experience.
So does that mean that you would have to like actually go to the air traffic control towers themselves, or would you be testing them in your own laboratories?
Yeah, they build labs. So our company, they'll build labs that use the real hardware and software. So you have different releases. So you have to retest it with each like major or minor release to make sure that like nothing that you have incorporated into the code has, like broken anything else. So we did have a lab that has, like multiple positions, the national data center software, and you can do like a lot of different scenarios that would be like that are critical to make sure don't fail out in the field. So yeah, I didn't have to go all the way to like DC. It definitely was just now our office is in Gaithersburg, so I just had to go to Gaithersburg.
Ah, okay. And so how would you ensure that the code had that resiliency, I guess, when you're doing the test engineering? Because obviously if the book just drops on the keyboards and it back like mashing a bunch of buttons and you
Mhm.
can't be fixing the code right then, is there a way that you ensure that it has that stability?
So it is kind of like cyclic, where like if we found that it did cause an error, you just pull the error logs and you send it back to software, and
Mm,
then test engineering was done at that point. So we didn't actually need to do any debugging ourselves. It was essentially like you find the problems, then you write. They have like sometimes different tickets, ticketing systems where you essentially like open a ticket and then send it back to software. Yep.
okay. Yeah. And I guess um with a lot of the, I guess, how do I put this? I think some of us have seen, there has been a couple of crashes recently, and
Mhm.
people are thinking, with air traffic control, whether that's something that's a problem on their side or is it a problem with the pilots? If you have any insight, I'm not sure if you would like to share anything.
I don't think I have that much insight. So I know with like the recent ones, some of them were like possibly, like pilot error or like due to understaffing. So the only one that was kind of tangentially related to our systems was like a few years ago, they had like NOTAM issues, which grounded flights for I think like a few hours. And that also was that was not us, but because we ingest the data, but a lot of the like interface data that you get is actually run by the FAA, and we just take that data and then process it to display on a screen. So a lot of the infrastructure, even that we rely on to get the data that we need in our systems, is like government owned by the FAA. So I think that with some of the recent incidents that we've seen in aviation, it's not due to like air traffic control systems, but like, you know, increasing demand for like higher volume into, like airports for essentially like money and possibly like understaffing issues. So like not meeting the workload personnel wise with,
Mhm.
the demand that airlines are trying to push on to get more money essentially. So
So I guess in in the context of working with the government, I guess looking before and then looking to the present, how would you rate the job security that a lot of these systems engineers have, and I guess specifically at your company as well?
I think except for unfortunately this past year, like our company and our division specifically had actually been really good about because all of these programs were under one division, you could essentially like swap between programs or swap between I guess like groups depending on which one had more work. And so I think they were pretty good about like if you made yourself someone who is like known for doing good work, the like management would essentially try and find a home for you wherever there was work that needed to be done, even if it was something that you hadn't previously done before. It kind of goes back to what I was talking about that if you show that initiative and you have um like the attitude that you can do anything that you try, like you're willing to learn new things, that having that it increases your job security because people will be willing to take you on if like management will vouch for you or your team lead will vouch for you, that kind of thing. So I think that I'm thankful my job is very secure. It's actually almost been too secure where they're asking us to work overtime and that kind of thing now. um but yeah, I think it really is people that like even now as manager that we really fight for the ones that are like, yeah, you've done great work on these like 5 different areas, so I know no matter where you go you're going to be a valuable asset to whatever team you go to, and you really like fight harder for them.
Hmm.
Yeah.
And you also talked about how you're able to travel a lot. So I was wondering how you rate the work-life balance at Leidos.
I think that it really depends on what, because I've even heard things about different like groups as they call them. So we're under like the civil group, and then they have like defense, health. I think we combined health now. We did like reorganization last year, but even within different groups, the culture was a little bit different. So I think that the division I'm under now actually used to be part of Lockheed Martin, and so it has a very like technical culture where I think people really value their work life balance. Not that like I think there's a stereotype that like corporate jobs, like actual like corporate jobs or like banking jobs have like worse work life balance because they expect you to hit certain milestones no matter how many hours it takes. But in my experience, I found that the more like technical side people have more um like discretion with making sure that they separate like work from leisure. So they try not to bother you off hours. They ask like if they do need you to work overtime, it's like an ask, it's not a demand. They understand if like need like if you're taking time off and you're not gonna have your computer, they're not gonna call you on your personal phone and be like, we need you to answer this question right now. So I think I've been very lucky that like the culture that of the division I'm in is very like they respect your time away from the computer.
Mhm. And for us high schoolers, like this is, I guess, a little bit far for us, but what would you think is important for us when we're looking for a job? I guess anything with like job security or work-life balance, or even like things like insurance or benefits. Is there anything that you think is important to look for when you're going for a job?
Um, I do think that like company culture is kind of a big thing, but it's kind of hard to vet that without working there. Um, to me, I think it depends on like your own personal case. If you have like extenuating circumstances that you might need better insurance. For me, I didn't really look at benefits that much because most companies will have like different tiers. So if you're willing to pay more for better insurance, that's always an option. Um, I think that work-life balance is actually really important. So if you're taking a job that maybe is not like your passion, but is something that you can do consistently, 40 hours a week, which is a lot of your time. Um, and you want to kind of like help you fund your hobbies and interests outside of work. I always say like there's nothing wrong with that. So some people don't want to climb the corporate ladder. They just want something where they can, put in their 40 hours, get their paycheck, and then do what they want to pursue outside of work. And like there's nothing wrong with that either. So I think it really depends on what you value. Like, do you value, like climbing the corporate ladder quickly, getting more money and then, retiring early? And are you willing to put in more hours to do that? So if that's something you want to do, I would ask about like internal mobility. I would ask about like what opportunities they have for um, not bonuses, but like career advancement essentially. Like, do they have programs that are designed to help people, like advance their career quickly or aggressively if that's something that they want to do? If you're looking for more of that, like put in my 40 hours and get out, the way you can ask that professionally is um, uh, kind of asking about the corporate culture. So, like, let me try and phrase it well, so you guys don't go in and be like, "Yeah, do you make me work overtime?" But I think you can ask like, is overtime often expected, and if so, how often? So you're not giving away whether like, are you willing to work overtime or not, but it gives you that information about whether they generally expect it or not. So I think it really depends on like what you value. So if it's like money, job security, doing something you enjoy, you have to find something that kind of meshes all those things together.
Yeah, I just have one more question before we open the floor to questions from the audience. Um, I guess as a high schooler, many of us are kind of like getting into that time where we're nearing or already past the college application processes. Do you have any words, I guess, going through that to kind of like what are some wise words you would say, having lived in that
I'm a
experience?
very bad person to ask for this, because I think that the student athlete track was like a very different process than
Uh,
what most I think students have to face. So yeah, I think that like when you commit to a school for athletics, um, generally you don't apply to more than one school. So I was very lucky that I
hmm,
only had to apply to Illinois, and with my like general grades and SAT scores, like it was like I knew I was gonna get it essentially.
oh,
So
okay.
um I definitely would say like at least pick something that not like safety schools, but um like I know that finances were definitely something that I had to consider a lot when I was choosing which school to commit to. So is this balance between like if I knew what I was gonna major in, like how recognizable was that school? Like how much money would it have cost, right? Like what was my likelihood of getting in on a scholarship in that case? So I think most students can still kind of follow that process, even if they're not going the athletic track, but like figuring out if you know what major you want to do, like is prestige important? And then is prestige worth the money that you'd pay if you're going out of state and you're not getting any kind of financial aid? And then picking ones that are, maybe like less prestigious, more affordable, but like have a like environment that you like. So I think that once you do like college visits and that kind of thing, it really can change your feeling about a school also. There were some schools that when I was swimming, we had meets at that I was like, oh man, I would never go to school because the vibes are off. So even that kind of thing, I think is you can still carry over even if you're not an athlete. So, yeah.
Okay. I guess, well, with that, that concludes the interview portion of this seminar, I guess. But now, if there are any people who have questions, they can message them directly to um, me, I think, or you can just drop it in the chat and we'll ask them to Ms. Trong directly.
Yeah, we'll give it a few minutes so that people have time to type because I know it's not always the fastest way to do this.
I have to say it's so weird to be called Mrs. Chuang. I feel so old. As a coach, people will just say like Cara or Coach Cara. So like, oh, I just aged 10 years.
I'll try to be formal here.
I don't have any questions here yet, but we have a small enough group. Do you want to do it any other way, or are you getting any questions on your side?
I do actually have one question
Okay.
so far. Uh, I guess uh, someone was asking about how you apply math skills since you mentioned stuff about, heading, and I think those are terms that are familiar to us from our calculus classes. So how do you apply your math skills into your job?
So my current role, I don't. So when I was talking about headings, it was like what you see on the screen that the controllers use. So it just essentially tells you what direction the airplane is pointing in. And so the most math I actually had used was my first role, the specialty engineering team that I was on. We did performance, which is like when you input something into your like keyboard. Essentially, there's like a bunch of processes that need to be run before something pops up on your screen. So there was like performance threads that you had to like model, and then there's also like reliability. So if you have like a piece of hardware, that's going to fail, like 0.01% of the time, then you have like a thread that's going to fail like 0.01% of the time. You have another thread that's related that might fail like 0.01% too. When you combine all those kind of probabilities together, you get like certain reliability metrics that say like it's gonna like this part of the system or this thread might like fail or take longer than the specified amount of time. Like one out of every like 600 times or like 1,000 times that's wrong. So besides that, I haven't used much math. I think a lot of it is um yeah, just more analytic thinking, but I haven't had to do like integrals or differentials in like 15 years. So yeah.
Um, let's see. I don't have another question so far. I don't know if Miss McDonald has one.
Nope, I don't see any questions on this side, which I'm kind of surprised about because I feel like this is a profession that a lot of our students are interested in. Oh, we just got a new question.
Okay,
Yep, I see too. But you can go ahead and read, Michael.
so
Yep.
yeah, Alexander is asking, according to your job description, what is the difference between the systems management and project management?
So at our company, systems management is like if we talk about like management by itself, it really is like you're managing personnel and like a specific part of the process. And that's like the technical writing or the special engineering group or the tech manual and training, which all falls under kind of that, like we call it SC umbrella. But then project management, the programs that I've seen use that are generally smaller programs where the project manager like oversees the entire development end to end. So I would almost say like in our like the program I'm working on, there we have like a chief engineer, which I would almost consider that a project manager, but she oversees like all the technical things from software, all from systems engineering all the way to like implementation, which is deploying it out in the field. Um, I'm trying to think like on our program, I don't think we technically have any roles that are called project management, but what I've seen in like smaller programs is that generally it's like owning the entire process from end to end, um, both on the technical side, but also getting into like schedule and cost management also. So I was like, I only know project management, tangentially, so take that with a grain of salt. But yeah, I think there are a lot of different roles that are called different things within different companies, but you're doing similar jobs. So, yeah. No problem, Alexander.
Do we have any more questions? Oh, there we go.
Jocelyn, I think you know her. Well, she is asking, do you think it's easy to switch from one field of engineering to another?
I think that I have to say that I think software engineering is definitely the most flexible for sure. Um, Not that systems engineering is not hard, but I think that a lot of times the it's harder for someone who didn't have an education in coding to pick up coding than it is for someone who had an education in coding to pick up using like modeling applications or like writing technically, because everyone has like an English background like from high school right now, and it's easier to go from like more technical to like slightly less technical, which I would say system engineering is less technical than it is to go from like not having a really strong coding background to actually doing pure coding as your day job all day. If you're talking about from um, like mechanical engineering to bioengineering, I think one advice that I tell a lot of people that are thinking about going into bioengineering is that if you're looking to be marketable across a lot of different industries, but you are interested in the bio field, I think it actually would have been better to go into mechanical engineering and then specialize in like biomechanics, as opposed to doing bioengineering and like specializing in like signals. Because I think that a lot of the way the job market worked, at least when I was applying for jobs, was that they would have certain majors that they would only interview. So getting your foot in the door with a broader major was easier if you did like electrical engineering, computer science, with like maybe a focus or a minor in like whatever interests you, so like biology or cell and tissue engineering, whatever, as opposed to having a bioengineering degree, even if you had like taking classes that required coding. So yeah, I definitely think like if you're looking for to be marketable, and the industry's changed now, so it's hard to say, but the broader engineerings are easier to get your foot in the door, even if you want to specialize in a certain industry. Yep. Feel free to ask about anything. I was like, I also know Jocelyn outside of here also from coaching her. So I think Michael and Jocelyn can both attest that I'm pretty friendly. No, no hesitation to ask any questions you guys have.
Alex is also asking, how is AI changing your job?
So actually it's pretty funny because so the team that I work with right now, the tool that we work in called Storyline, which I mentioned before, actually introduced like an AI assistant feature like back in September. And originally, so the training we're developing is essentially like if you have to take an online course, you have to like click through slides and it narrates stuff at you. And so when this AI assistant came out, it used to have really, really clunky text to speech. And now this AI assistant is like, oh man, this sounds like a real person talking to you, except they pronounce certain words really badly. So in that case, it was actually helping the product that we were working on, because originally the text to speech was so bad that our customer had said, like, you can't use it. Like, you have to hire a voice actor and have someone narrate it. But then when this new feature came out, they're like, oh, actually, it's good enough now that you can use it, which saved us money and takes less time. I think in other areas, a lot of times we use like AI as a little bit of a buzzword. But for like our internal research and development, we would call it like machine learning or AI, but it really was just like pretty advanced algorithms based on existing data that helps you, or that improved system like results. So I think we call it AI, but it really was just like you have a bunch of data that now you have very efficient processing methods to have more accurate predictions for the future. So yep, I kind of answered that on both like the end user of one and how we're implementing AI.
Well, I guess we'll have time for one more question if anyone does not. We'll wait for a minute. Okay. So I guess this will be our last question. Mira asked, do you have any tips for getting into leadership roles later on?
Yeah, I think that at least within Leidos, it definitely was if you show you have the attitude to like get what needs to be done. So if you're like if you have something you're taking ownership of, or okay, let's say you're assigned like a certain piece of a project, but then you say like, oh, like I can help more because I have time and I can finish this, quicker than what you had allotted for me originally. I think taking that I keep saying initiative, but taking that initiative to, like take on work beyond your initially scoped role will help show that, like I can think outside the box. I keep using all these buzzwords, it's killing me, but I think it helps show that, like you're able to do things that haven't been done before to help improve, like your work experience, the people that are on your team's work experience. And then if you like express that to your manager or like your team lead, when opportunities come up where it's like, oh, so and so is retiring and we need a new, like team lead for that test team, and you say like, oh, I'm interested in taking a leadership role, and you have that history of like doing good work, it's more likely that people will like say you're a good fit for it and then help like move you into that role essentially. So I think it pretty much is just like doing good work, like having that information out there, like not just holding it in, but really like expressing it to people that can help transition you to that role. Is a good way to manifest, I guess, the things you want to do in your career.
Yeah. I guess with that, we'll be concluding our meeting today. Thank you so much, Ms. Chuang, for joining us, and thank you for everyone who has joined. I'm just gonna take a picture of the attendance just to send to the SNHS officers. Thank you everyone for joining. And again, thank you so much for joining us, Ms. Chuang.
Yeah, thanks again for having me.
And
If you
thank
ever have
you
any
so
follow-up
much.
questions, yeah, Michael knows how to contact me. So if you think of something later on, like let him know and you can pass it along to me. I'll do my best to answer. Yep.
And then we are so excited that this is our second episode of our Insight from the Inside that Michael and some of the other members of our College Career Readiness Club at Wootton have come up with. And we are already working on some of our next episodes to come. And so we're always welcome to suggestions as well. So if you have any, you can contact me. You can contact Michael if you're at Wootton. I know we're working on looking at getting like an orthopedic surgeon as a possibility and some other things. So hopefully you guys will be hearing from us soon with our next episode. And just as a reminder, we did record, and I will have that up on the Wootton College and Career website. All right. Thank you guys so much.
Thank you guys. Good night.